Now we're solving problem D. Again, we're taking the derivative of an x that shows up in both the numerator and the denominator of our function, so we will be using the quotient rule formula that we've already listed to the left of this page. My numerator is my f function, and the derivative of that, since this is a basic base exponent, is just, the 5 coefficient times the 3x squared, but I'm sure you just thought 15x squared without even going through any steps anymore. Our denominator, the g function, is exponential, so first I need to copy the question, take the natural log of the base. This time we must keep the natural log of the base because it is not the letter e, the natural number 2.71, etc. It's an actual different numeric value, so this will not simplify to 1. And the derivative of the top is a 2. And so cleaning this up, we tend to write the 2 natural log part first. And I know it's a little hard to read my exponential, but it's the 3e to the 2x. So now I'm ready to put all the parts into place. So the first thing we do is f prime, and our f prime is 15x squared. Then the formula says to write g in its original format, which for us is the 3 to the 2x power. Then we have minus, and the original f function, which is 5x cubed, times g prime, which in its cleaned up form is 2 natural log of 3 times 3 to the 2x. And this is all over the denominator squared. That can be cleaned up, but we're going to leave it as is, which so far has been our tradition with denominators. You generally do want them factored. Okay, so as I go to clean it up, I look at the first term. I cannot multiply the 15 and the 3 because the 3 is not an independent variable, not really the correct term, but basically it's the base of an exponent. It's part of something else. So we don't even know how many 3's we're going to have. It's going to depend on what x is. So I can't multiply the 15 and the 3. The x squared doesn't multiply. And basically this first term on the left of the minus sign is exactly what the derivative is going to look like. There's nothing to do to it other than I could maybe drop a bracket. Now when it comes to the right side after the minus, this 5 and the purple 2, neither of them have exponents themselves. They're multiplied to other terms, but because it's straight multiplication, I can multiply the 5 and the 2 to get a 10. Next I see an x squared, which generally is, x cubed, which is the next term, and there's nothing to multiply it with. My natural log of 3 needs to come next, and my exponential term comes last. But I don't want it to look like the natural log of 33, so I put everything before the exponential in parentheses, all over that same denominator that we're not touching. Okay, as I look at my derivative so far, those lead coefficients, the 15 and 10, both have a 5 in common, so I am going to be able to factor further. My derivative of m is going to factor 5 out. Now when I look at the next set of terms, I see an x squared and an x cubed, and since the smaller exponent is squared, then I'm going to factor an x squared out. The final piece of my first term is a 3 to the 2x, and when looking further, there is a 3 to the 2x power on both sides of the minus sign, so that can be factored out. And I've checked every term from the first part before the minus sign, so there's nothing further that could be factored out. So 5 factoring out of 15 is going to leave me with a 3. X squared, factoring out an x squared, all of the x squared, so there is no x squared. The 3x squared, it's going to take the whole 3x squared. There's nothing left after that 3. I can go ahead and write the minus sign. Repeating this process, 5 factors out of 10, leaving me with what? A 2. X squared factors out of x cubed. If I'm taking 2 away from 3 of them, I still have 1 left, or x to the 1. And the 3 to the 2x power all factors out, so I'm done. Oh, I missed that ln, right? That was the only thing that was left. All over my original denominator. Now at this point I should be done, but hopefully something catches your eye. There is a 3 to the 2x power in the numerator as part of a product, not part of a binomial. and as a single product or part of a squared term in the denominator. So instead of leaving our denominator as something squared, because squaring means to multiply a term by itself twice, let's cross this off and write that term physically multiplied by itself twice. Because now I can cancel a 3 to the 2x power from the numerator with a 3 to the 2x power in the denominator, and I'm ready to write my final answer. I still have my 5, my x squared, but then I go right into the parentheses of my binomial, 3 minus 2x ln of 3. And then remember, my denominator just has a 3 to the 2x once, so I don't even need the parentheses, and I am done. I've got my answer.